Hey, Precalculus, here we go with section 12.2. It's on arithmetic sequences. Now, this is a specific kind of sequence. All right, here's your definition. A sequence is arithmetic, all right, if the difference, when I subtract, between successive terms is constant. Constant meaning always the same number, just in case you're an idiot and don't know what words mean. The constant difference is usually written as, just D. Okay, so what that means is if I take any number in the term and I subtract the previous term, I get the exact same number. No matter which one I start with, if I subtract the one before, I get the same number. What does that mean? As I'm going forward, I'm adding the same number every time. That's what that means. So here's a recursive formula. A sub 1 is equal to, whatever the first number is. And then a sub n for any term, you go to the previous term and you add the common difference. Constant difference, whatever we want to call it. So look, here's the first 6 terms for each one of these. A sub 1 is -5. Okay, so I have -5 first. And then to get a term, so like the second term, I go to the previous term, which is this -5, and I add 7. I get 2. Then to get the next term, I go to the previous term, which is 2, and I add 7. So 9. And then I add 7. So 16. And I add 7. So 23. And I add 7. So 30. In an arithmetic sequence, you're adding the same number every time, and it's called the common difference. The second one, I start with a 12. I go to the previous term. To get the second term, I go to the previous term, and I subtract 7. So 12 minus 7 is 5. And then 5 minus 7 is -2. And I'm going to have very similar numbers because I'm adding a very similar number here. There you go. Add -7 over and over and over, and that's what you get. To determine whether a sequence is arithmetic, you should subtract 2 terms. The nth term minus the n minus 1, the n minus 1th term, if I'm probably making up something right there. So take a sub n and subtract a sub n minus 1 as formulas and see if the difference is constant. The common difference. If you have something that's not arithmetic, when you subtract these 2 terms, it won't end up simplifying to just a number. Okay, so a sub n equals 3n plus 5. Okay, so that's a sub n. That's this one right here. I would like to know what I get when I have a sub n minus 1. So here's what I'm going to do. I'm going to go a sub n minus 1 is 3 times n minus 1 plus 5. I just put an n minus 1 right there. Okay? And so if I distribute this, it's 3n minus 3. And then when I add the 5 there, it'll be 3n minus 3 plus 5 is plus 2. Okay, a sub n minus 1 is 3n plus 2, and a sub n is 3n plus 5. So now I'm going to go a sub n, I'm going to do this trick right here, minus a sub n minus 1, and I'll see if I get a formula with n. If I do, it's not arithmetic, or I'm just going to get a number, then it is an arithmetic sequence. So look, 3n plus 5 minus, in parentheses, 3n plus 2. Got to put those parentheses there so I know to distribute this 3. So look what I get, 3n plus 5 minus 3n minus 2. That 3n minus that 3n cancel, and 5 minus 2 is 3. So yeah, there's a common difference here, and it is 3. So you don't have to write this in your notes if you don't want, but let me write the first few terms. Now this is not a recursive formula. This is an nth term formula. So if I put a 1 in, 3 times 1 is 3, plus 5 is 8. If I put a 2 in, I get 6, plus 5 is 11. If I put a 3 in, I get 9, and 9 plus 5 is 14. If I put a 4 in, I get 12. 12 plus 5 is 17. If I put, where am I at 5? Put a 5, 15 plus 5 is 20. It goes on and on, right? Look, aren't I adding 3 every time? 9, 10, 11, 12, 13, 14, 3, 3. I'm adding 3 every time. This one is arithmetic, so I'm going to write down at the bottom. I didn't leave myself much room for that. My bad. Check. That one is arithmetic. Now we're going to look at n squared plus 1. Okay, let me go over to the side here, and I'm going to find b of n minus 1. So that would be n minus 1 squared plus 1. Well, I got to write this out and multiply it. That's not going to be fun. N minus 1 times n minus 1. I mean, we've done work like this before, right? And we're getting pretty good at this. That's going to be n squared minus n minus another n, and plus 1, and then the plus 1 after. Okay, so I have n squared minus 2n plus 2. That is my a sub n minus 1. Actually, it's b sub n minus 1. Okay, so here I go. I'm going to go b sub n minus b sub n minus 1. And I'm looking to see if everything cancels and I get just a single number, which would be the common difference. Okay, so I have n squared plus 1, and it's minus, in parentheses, n squared minus 2n plus 2. Okay, I'm going to distribute that negative, and I get n squared plus 1 minus n squared plus 2n and minus 2. The n squareds cancel, that's good, but this doesn't. I end up with 2n minus 1. That is not a constant difference, so this is not arithmetic. Once again, if you want me to prove it, let me find the first few terms here. Again, this doesn't have to go in your notes. What you have to do is figure out if it's arithmetic or not. We're done. But I'll show you. Put in a 1. 1 squared is 1 plus 1 is 2. Put in a 2. 2 squared is 4. 4 plus 1 is 5. Put in a 3. 3 squared is 9. 9 plus 1 is 10. Put in a 4. 4 squared is 16. 16 plus 1 is 17. I'll stop right there. You can tell I added 3. I definitely did not add 3 here, and I didn't add 3 here. I added 5 here, and I added 7 there. So there might be a pattern to it, but it's definitely not the case that you're adding the same thing every time. Yeah? All right, so let's go to page 2. On page 2, these arithmetic sequences where I add the number at the same time. Let's check one more because I got a minus sign in there, and it looks all complicated. So negative 2 minus 5n. Okay, here we go. I got to find the formula for n minus 1. C of n minus 1 would be, let me put an n minus 1 in there, negative 2 minus 5 times n minus 1. And let's simplify that if we can. I have negative 2 minus 5n plus 5. And so we'll call it negative 5n plus 3. Get my hand out of the way so you can read that. And so I'm checking to see if negative 2 minus 5n is an arithmetic sequence. So here we go. I'm going to find C of n, and then I'm going to go minus C of n minus 1. All right, it's negative 2 minus 5n and a minus sign, and in parentheses, negative 5n plus 3. If everything cancels out and I'm left with a number, that's the common difference. So let me distribute this negative. I got minus 2 minus 5n plus 5n and minus 3. I got to distribute that negative to both terms. Well, the 5n's cancel, and I get negative 5. So yeah, that's a common difference. This is going to be arithmetic. Let me show you. I'll put in a 1. Negative 2 minus 5 is negative 7. I'll put in a 2. Negative 2 minus 10. Negative 2 minus 10 is negative 12. I'll put in a 3. Negative 2 minus 15 is negative 17. I'll put in a 4. Negative 2 minus 20 is negative 22. Now look what I'm adding every time. I'm adding negative 5. Negative 7 plus negative 5 is negative 12. Plus negative 5 is negative 17. Plus negative 5 is negative 22. Yes, this is arithmetic. So there's your trick for today. If you want to check to see if something's arithmetic, you could just generate terms and see if there's a constant difference. I mean, I think that's easier. But if you want to use the formulas, we could use the formulas. Okay, watch the pattern happen because we're going to come up with this nth term formula. That is not recursive. We're going to come up with a nth term formula. Here we go. A sub 1 is 5. Ooh, excuse me, had to yawn there. A sub 2 is going to be 5 plus 2. This is going to be 5 plus 2 plus 2. 5, 6, 7, 8, 9, right? The third one is 5 plus 2 plus 2 plus 2. I'm going to add 3 2's here. 13 is what I get when I add 4 2's. You can see, since every time I go from term to term, I'm adding 2, right? I'm adding 2. I'm adding another 2, adding another 2, adding another 2. So if I go from where I started to get to this point, I had to add 1, 2, 3, 4 2's. 1, 2, 3, 4. 5 plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13. See how it works? Okay, I don't think I need to write the next one. I do want to write it this way. Look, this is 5 plus 0 times 2. This one's 5 plus 1, 2. This one is 5 plus 2 2's. 5 plus 3 2's, 5 plus 4 2's, and on and on and on to the point where you get 5 plus a whole bunch of 2's. And how many are there? Well, look what's going on here. For the first term, none of them. For the second term, 1. For the third term, there were 2 of them. For the fourth term, there were 3 of them. The first one didn't have a 2. I don't start adding 2's till I get to the second one, so I'm always 1 behind. For the fifth term, there's 4 2's. So there are n minus 1 of these. This is 5 plus n minus 1 times 2. So what I'm saying here is if I wanted the 100th term, I would add 99 2's, wouldn't I? Just go 99 times 2 and then add it to 5, and I would find the 100th term. So look, it's a theorem. If a sub n is an arithmetic sequence, the formula for the nth term is a sub n equals a sub 1 plus n minus 1 times the common difference. Okay, so let's find the 52nd term of this sequence. I need the first term, I need the number I'm looking for, 52, got it, and I need the common difference. Well, what am I adding here every time? The common difference is any of these numbers. I'll pick the 14, subtract the number in front of it. 14 minus 10 is 4. Pick any of those numbers and you can see 18 minus 14 is 4. 6 minus 2 is 4. If I know it's arithmetic, just subtract and find out what the common difference is. Now the first term is clearly 2, and the n that I'm looking for the 52nd term. So here we go. The 52nd term, I just put a 52 in there just to let you know what I'm finding, is the first term 2 plus 52 minus 1 times 4. So it's going to be 2 plus 51 times 4, and 2 plus 51 times 4. The 52nd term, so I'll write it a sub 52, is 206. That's a lot quicker than generating 52 terms and keep adding 4 times every time just to figure out what the 52nd term is. Hey, let's go to page 3. You're doing great so far. I'm very proud of you. You guys sound very smart today, even though I can't hear you. Don't even know if you're paying attention. Okay, some problem solving. If the 8th term of an arithmetic sequence is 75, the 8th term of an arithmetic sequence is 75. Remember, that's a pair of numbers. It's an x and a y, right, from a function. The 20th term, a sub 20, is 39. Find the first term, which is a sub 1, and the common difference, which is d. Okay, well, look at this. A sub 8 would be a sub 1 plus 8 minus 1 times d. That would have to be true. At the same time, that a sub 20 would equal a sub 1 plus 20 minus 1 times d. Those both have to be true at the same time for this to be a real sequence, right? So watch what I'm going to do. Remember this from Algebra 1? I'm going to solve a system of equations. And it's real easy to do. Ready? Okay, the 8th term was actually 75. So I'm going to actually put the number in there, okay? I'm going to make a system of equations. It's super easy to solve. 75 is equal to the first term plus 7 times d, right? 8 minus 1 is 7. And the 20th term, which is 39, is a sub 1 plus 19 times d, right? Now, how did you solve systems of equations? If you had two variables that were the exact same, you could just subtract the two equations. Remember this? This is from a long time ago. 75 minus 39 is 36. A sub 1 minus a sub 1, those cancel. And 7 minus 19 is negative 12d. And so look, all I got to do is divide by negative 12, and I find out that d is actually equal to negative 3. Okay, and once I find that out, if you remember how these go back to either one of these equations and put a negative 3 in for d and solve. So I'll go with this top one because it's convenient. 75 is equal to a sub 1 plus 7 times negative 3. Well, that's negative 21, so I'm going to add 21 to both sides, and I get a sub 1 is equal to 96. Problem asks me to find the first term, it's 96. The common difference, negative 3. Little system of equation. No big deal for you guys. Okay, find the formula for the nth term, well, I was just using it a second ago. It's a sub n is equal to a sub 1 plus n minus 1 times d. And the things that you put in there are the first term and the common difference. And I have them now. So here we go. A sub n equals 96 plus n minus 1 times negative 3. Okay? But no self-respecting math person would leave this number outside of these and call this simplified. Let's distribute this and clean this up a little, shall we? Here we go. Make a little room here. We'll move this up top and we'll say a sub n is equal to 96 minus 3n plus 3. Negative 3 times n is minus 3n. Negative times negative is plus. And then let's write this like we should. Negative 3n plus 99. There you go. That looks a lot more simplified than that. No, we can't leave it like that. It's ridiculous. Okay, now that we have that, let's find the 100th term. Well, all I got to do is put 100 right there. A sub 100, it's nice and easy. It's negative 3 times 100. I'm using this formula right here. Negative 3 times 100 plus 99. Okay, so that's going to be negative 300 plus 99, and negative 300 plus 99 is negative 201. The 100th term would be negative 201. I suppose we could have put the 100 there and put 99 times negative 3, and then add 96. Either way, it works. Give a recursive formula. Okay, what's the first term? The first term is 96. So here's how recursive formulas work. Okay, the first one is 96. We use the word and we try to define how you get the next term. Well, if this is arithmetic, and the common difference is negative 3, I just add negative 3 every time, right? So a sub n is equal to the previous term, a sub n minus 1. Probably the hardest thing to get used to is just writing this stuff. Minus 3. There you go. To get any term, you just subtract 3. List the first 6 terms. All right, 96. Subtract 3, 93. Subtract 3, 90. Subtract 3, 87. Subtract 3, 84. Subtract 3, 81. Pretty easy stuff today, I think. Okay, now for the sum of the first n terms. We spent some time with sums in the last section. We learned that the sum of the first n integers is n times n plus 1 divided by 2. Well, the reason that's true is because we start with 1. We're looking for the sum of any arithmetic sequence. See, that one doesn't start with 1, so this formula really wouldn't work for that. But the formula is kind of close, so we'll go to our last page here, page 4, of what I think is a fairly simple section today. Here's a formula for the sum of any arithmetic sequence, regardless what we have for a sub 1 or d. Ready for this? Your sum formula for any arithmetic. It's got to be an arithmetic sequence to use this formula. It goes like this. I write s sub n meaning sum. I'm adding everything up. N over 2 times a sub 1 plus a sub n. It comes from that formula that we used last week with the first n integers. It's very similar. So here's the last thing we're going to do. We're going to find 4 sums. Ready? Use the sum formula to find the sum. Well, a sub 1 is 4. A sub n is 49. And I need to know how many terms there are. So count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N equals 10. So this is easy. The sum of these first 10 terms is 10 over 2 times 4 plus 49. And over 2 times the first one plus the last one. And why am I adding those? This goes back to this. If I put 4 here, and then I put 9 here, and then I put 14 here, and I added all of them up backwards, and I end up with 49 here, all the sums are the same. It's 53, 53, 53. So I add the first one and the last one to create that. I multiply it times how many I have, and I divide by 2. So I put this in the calculator. It's, well, this is 5 times 53. You almost don't even need a calculator. It's 265 is the sum of those first so many terms. I will give you a real good reason by the end of this semester why we would want to start adding things up in patterns like this. So if you're thinking, why would I ever want to know that? I got you. I got a real big reason in the middle of a real big problem coming up towards the end of the semester, well after spring break. Okay, second one. Well, this is a little unfair. With that in there, I don't know how many terms I have. It's not fair to just count 1, 2, 3, 4, 5, and then call 6. You don't know how many are in here, right? So n equals, what the hell, it's at least 6. But I do know the first one and I do know the last one, right? So here's what we're going to use. We're not going to jump into that formula because we don't have everything. I do have the first one, I do have the last one, but I don't have n. So use the other formula. A sub n is equal to a sub 1 plus n minus 1 times d. See, I can find the common difference too. Take any number, 36, and subtract the number before it, 39, you get negative 3, right? So look, a sub n is negative 6. I can put that in for the last term. 48 can go in for the first term. N minus 1 I don't know, but I know this is negative 3. Look, it's algebra. It's real simple algebra, actually. Okay, so I'm going to subtract 48 first. I'm just going to go subtract 48. I'm solving for n here, so I'm not going to distribute that. I'm just going to keep moving things away. So let me go back up to the top here. Negative 6 minus 48 is negative 54, I think. Negative 54 is equal to n minus 1 times negative 3. Well, again, I'm not going to distribute that. I'm just going to divide by negative 3 to get rid of it. Divide by negative 3. Negative 54 divided by negative 3. 3 goes in here once. 3 goes into 24 8 times, right? So this is 18 is equal to n minus 1. So when I add 1, n is actually equal to 19 for this problem. So here you go. The sum is equal to 19 over 2 times the first one, 48, plus the last one, negative 6. Put that in the calculator and you get 399. The sum of the first 19 terms, that sum right there, is 399. Okay, let's see about this one. What do we got to do here? I'm going from 0 to 22, so I'm going to tell you right away, n is equal to 23. If you don't see why, I don't start with 1. I start by putting in a 0. Then I put in 1, 2, 3, 4, 5, up to 22. So it's the 22 from 1 to 22, but that 0 makes the 23 terms. All I need is the first term and the last term, and I can go find the sum. So a sub 1 will be what I get when I put a 0 in. 3 times 0 minus 5 is negative 5. And a sub n is what I get when I put a 22 in. 3 times 22 is 66, and 66 minus 5 is 61. Well, there you go. That's all I need. The sum for this 23 terms that I would generate, I don't even care what the terms are. I just need to know what the sum is. It's going to be 23 over 2 times the first one, negative 5, plus the last one, 61. 61 minus 5 is 56. Then you can divide 56 by 2 and get 28 times 23. I get 644. You just put the whole thing in the calculator, really. Okay, find the sum of the first 100 terms of this hot mess. Well, let's see. N is equal to 100. I need that. A sub 1 is equal to negative 17. I need that. And a sub n is now a question mark. But I do have this other formula that can help me find it, right? Okay, so here we go. A sub n, looking for the 100th term, is equal to a sub 1 plus n minus 1 times d. What am I adding every time? Take any number and subtract the one before. So 7 minus negative 1 is 8. 15 minus 7 is 8. The common difference is 8. Okay, so I'm looking for the 100th term. The first one is negative 17. 100 minus 1 is 99, and it's times 8. So, if I take 99 times 8 and subtract 17, the 100th term is 775. So here I go. The sum of all these numbers is n over 2 times a sub 1 plus a sub n. That's how I find the sum. And so the sum of the first 100 terms will be 100 over 2 times negative 17 plus the last term, which we just found over here at 775. It's 50 times whatever 775 minus 17 is. I don't even care. Put it in the calculator and get 37,900. Hey, there you go. there's your notes on arithmetic sequences today. Two big things that we found: the sum formula and the nth term formula. I think those are the two real big takeaways. The other weird thing is when we had to, find a sub n and a sub n minus 1 and subtract them. I think that's weird. Maybe I'll put one of those on my math lab, but this is not anywhere near as important to me as you being able to write a recursive formula. So where did we do that? We found this formula. We wrote out a recursive formula somewhere. There it is. And then we found that sum formula. Those are my big deals for today. All right? A little bit of homework on my math lab. Have a good day, everybody.